Hello dear students, welcome back to another video. In the previous video, we had learnt about Earth's magnetism. The branch of physics which was dealing with that was called magnetism or terrestrial magnetism. And then we learnt about different definitions pertaining to this study, like axis, geographic axis, magnetic axis, geographic meridian, magnetic meridian, geographic equator, magnetic equator, and so on and so forth. Then we learned about different elements which are required to completely define Earth's magnetic field. Earth's magnetic field will be inclined to the Earth in some places. At equator, it will be horizontal, and all those things we have learned. And so, if the resultant magnetic field is in some direction, then what are the things we require to completely define that? We need the angle made by the magnetic needle with the geometric meridian, then angle made by the magnetic needle from the horizontal, and then the horizontal component. So these are the three important components or elements that we require to completely define the magnetic field of Earth. These angles were called angle of declination and angle of inclination and then the third element was the horizontal component. Now I told you in the previous video also, to completely understand the concepts of physics, visualization are required, that I showed in the last video. Apart from that, solving many numericals are also required. So that's what we are going to do in this video. I'm going to show you some of the good problems pertaining to this concept. So let's start. In this question, they are talking about at a certain place, the horizontal component of Earth's magnetic field is root 3 times that of the vertical component. What is the angle of depth at that place? I tell this to my students frequently. Whenever you are solving a problem, first of all, write the given data. What are the data that is given in the question? So it's when you read the question, that time itself you can write the mathematical relation so that you can clearly solve it. At a certain place, the horizontal component of Earth's magnetic field is root 3 times that of the vertical component. So that time itself you can write B with the subscript H is equal to, because horizontal component of Earth's magnetic field is root 3 times BV. So this is something that you get here. They're asking what is the angle of dip. Now if I can rewrite this by bringing BH to the other side. So BH will go to the denominator, and then root 3 also I can bring on the other side. So the equation will become 1 divided by root 3 is equal to BV divided by BH. But we know that BV divided by BH is nothing but tan of angle of dip, tan theta. We have seen that in previous slides, that tan theta is equal to vertical component divided by horizontal component. And with this, I'll just rewrite in, I'll make tan theta as the left hand side. So this will become tan theta is equal to 1 by root 3, or theta is nothing but tan inverse of 1 by root 3. So theta will be equal to tan inverse of 1 by root 3, which is nothing but tan inverse of 1 by root 3 is nothing but 30 degrees. So this is the angle of dip. We have found the angle of dip. It's a very simple question. Okay, instead of solving like this, if someone wants to solve by writing tan theta is equal to BV divided by BH, and in place of BH they can substitute root 3 BV. So BV will get cancelled, you will still get 1 by root 3. So whichever method you want to follow, you can follow that. So question number 1 was a simple one. Let's go to question number 2. Okay, so question number 2, a compass needle of magnetic moment is 60 ampere meter square pointing towards the geographic north. Okay, so in the beginning they said that there was a magnetic needle which was pointing towards the geographic north. That means you had held it there. because we know that magnetic needle will not be aligning in the direction of geographic north. It will be aligning in the direction of magnetic north, right? So we can say that someone had, you know, held on to the magnetic needle in the geographic north south direction. Then after that, where the horizontal component of Earth's magnetic field is 40 micro Tesla. Now it experiences a torque of 1.2 into 10 raised to minus 3 Newton meter. What is the declination of that place? So let's write the given data. So first of all, they are saying along the geographic north. So this is geographic north-south direction, north, and this is south. So geographic north-south direction, you have a magnetic moment of 60 ampere meter square. Now I want to bring a concept that you learned in the previous chapters. You had learned that magnetic dipole has a magnetic moment given by the pole strength into the length of the magnet. Now we don't have to use the pole strength or length of the magnet here. They have directly given the magnetic moment. Now if a dipole is kept in a magnetic field, in a uniform magnetic field, it will experience a torque which is given by, we have the equation torque is equal to, torque which is written as tau is equal to mb sine theta, where m is the magnetic moment of the dipole, and b is the magnetic field in that region, the uniform magnetic field in that region, and theta is the angle between magnetic field and the magnetic moment. Okay, now it is said that the magnetic moment is initially in this direction. So here it said the magnetic moment of this much value is pointing towards the geographic north. So it is given that magnetic moment is in this direction. Magnetic moment is in this direction. And then it is also known that 40 microtesla is the horizontal component of Earth's magnetic field. That means the the horizontal component of the magnetic field is along this direction. Okay, so this is the magnetic pole, magnetic axis, or magnetic meridian is along this line. So we have this angle. This angle is declination. We have to find the declination, angle of declination, or this was written as phi for our case. So phi or d you have to find. Clearly, it is similar to the equation that we see here. They are told that the torque is 1.2 into 10 raised to minus 3 Newton meter. So we can substitute 1.2 into 10 raised to minus 3 is equal to, magnetic moment is 60 ampere meter square into, what is the magnetic field? Magnetic field is 40 micro Tesla, 40 into 10 raised to minus 6 into sine of this angle. What is the angle there? This is sine of phi. So you need to find phi. So what we'll do is we'll write sine phi is equal to, you can bring this entire thing on the other side. So it will become 1.2 into 10 raised to minus 3 divided by 2400 into 10 raised to minus 6. Now 2400 can be written as 2.4 into 10 raised to minus 3, but 10 raised to minus 3, sorry, 2.4 into 10 raised to 3, and then you have 10 raised to minus 6 also there. So 10 raised to 3 into 10 raised to minus 6, it is 10 raised to 3 minus 6. Okay, so it will be minus 3. So again, this 10 raised to minus 3 and this 10 raised to minus 3 gets cancelled. You will be left with 1.2 divided by 2.4, which is nothing but 1 divided by 2. And we know that when sine phi is 1 by 2, phi is equal to sine inverse of 1 by 2, which is nothing but 30 degree. Well, it's a coincidence that first question also the angle was 30 and the second question also the angle is 30. I have told in the previous video that writing on the on the screen of the laptop is a bit tricky. That's why my handwriting is weird. This is not the way I write on the board. Or if I have a tablet, it will be way better than this. Anyway, let's continue. So I hope you have understood this. I repeat, the magnetic moment was shown to be in north-south direction, then geographic north-south direction, and the magnetic field is along the magnetic axis, and the angle between that is angle of declination. And we know that when magnetic field and magnetic moment is inclined by an angle theta, then the torque applied on it is mb sine theta, and accordingly we have found sine theta or sine phi in this case by equating the values. Now let's go to question number 3. If the dip circle is set at 45 degree to the magnetic meridian, then apparent dip is 30 degree. Calculate the true dip. Now clearly we have to write the data. The dip circle is set at 45 degree to magnetic meridian, meaning the vertical plane you have taken is, which is the random vertical plane we discussed in the previous video, is taken at 45 degree to magnetic meridian. So we will write, and you remember in that video we had taken that angle as alpha. So alpha is equal to 45 degree in this question. Okay, if alpha is equal to 45 degree in this question, and then apparent dip is 30 degree, and apparent dip we had discussed as theta dash. Theta dash is 30 degree. They are asking to calculate the true dip. We have a relation, the apparent dip tan theta dash, tan of apparent dip is equal to tan of true dip divided by cos alpha. We had seen this in the previous question, but they have given apparent dip and they are asking you to find the true dip. So we have to rewrite the equation in this way: tan theta is equal to tan theta dash into cos of alpha. Now just substitute, it's a very simple question. Tan of, what is theta dash? 30 degree, okay, into cos of 45 degree. So clearly tan 30 degree is 1 by root 3 and cos of 45 degrees 1 by root 2. So this will be nothing but 1 by root 6. So tan theta is 1 by root 6. So theta is nothing but, theta is clearly tan inverse of 1 by root 6. This is the answer. I hope it is clear. I am again apologizing for my handwriting. Let's proceed to the question number 4. Question number 4. A magnetic needle is free to rotate in a vertical plane, and that plane makes an angle of 60 degree with magnetic meridian. So magnetic needle is free to rotate in a vertical plane, and that plane makes an angle of 60 degree with magnetic meridian. Again, let's, without completing the question, let's write the data. This angle is nothing but alpha, which we have seen in the previous question also. So alpha is equal to 60 degree. If the needle stays in a direction making an angle of tan inverse 2 divided by root 3 with the horizontal, what would be the actual dip at that place? This is a similar question. Again, they are giving theta dash, but in this case theta dash value is not given. They have written it as theta dash is equal to tan inverse 2 divided by root 3. So 2 divided by root 3 is not a standard value, so this is not a standard angle, but we can write it like this. Now we can continue. They are asking for the actual dip. So in the previous question we had rewritten the equation like this: tan theta is equal to tan theta dash into cos alpha. This is how we wrote it, and we can substitute tan theta dash is tan inverse of 2 by root 3. So tan inverse of 2 divided by root 3, this is what you have to write, is equal to, into cos of 60 degree. So let's substitute tan of tan inverse. You can write, it's like getting cancelled. So you can write 2 divided by root 3, okay, into, what is cos 60? Cos 60 is root 3 by, yeah, cos 60 is 1 by 2, right? Yes. So cos 60 is 1 by 2 and it will get cancelled. You will get tan theta is equal to 1 by root 3, or theta is equal to 30 degree again. It's weird. We are getting all angles as 30 degree. Okay, so I hope this is clear to everyone. Let's proceed. Question number 5. If theta 1 and theta 2 are the angles of dip in two vertical planes at right angle to each other, and theta is the true dip, then prove that cot square theta plus is equal to cot square theta 1 plus cot square theta 2. Okay, now let's say theta 1 is the angle of dip. Now these are not true dips, these are apparent dip. You remember in the previous video when I taught you apparent dip and true dip, I told you that true dip can only be one and apparent dips can be apparently many. And I give you an example of soulmate and crushes. Just go back to that video and check it out. Okay, now so here let's say theta 1 is the apparent dip in a plane at an angle alpha, and theta 2 is the apparent dip in a plane which is 90 degree to it, meaning it will be 90 plus alpha or 90 minus alpha. It doesn't matter. Okay, so here what is the equation that we have? The equation that we have is, this is the equation, I'll write it here. Tan theta dash is equal to tan theta divided by cos alpha. So for the first one, we can write tan theta 1, which is the apparent dip in the first plane, that is equal to tan theta, where theta is the true angle of true dip, divided by cos alpha. Now, in the second case, we can write it as tan theta 2 is equal to tan theta divided by cos. In place of alpha, now we'll write 90 plus alpha. 90 plus alpha. Okay, you can write 90 minus alpha also, it doesn't matter. So yes, actually it will be better to use 90 minus alpha. I'll tell you why. Because we had learned that angle of dip, the angles that you measure should be acute angles. So we have to take acute angles, and if you write 90 plus alpha, you will get an obtuse angle. So that's why we will write 90 minus alpha. But I'm telling again and again, it doesn't matter, because you're getting a square here. You're taking a square here. When you take square, the plus, the positive and the negative value doesn't matter. The square will give you a positive value. Okay, anyway, so tan theta divided by cos alpha is the first one, and tan theta divided by cos 90 minus alpha is the second one. So this cos 90 minus alpha can be written as, so this will be tan theta 2 is equal to tan theta divided by cos 90 minus alpha will become sin alpha. I hope it is clear. If we had taken cos 90 plus alpha, we would have got minus sin alpha. Okay, because in the second quadrant, cos is negative. All silver teacups, ASTC, yeah, whatever. So, but we have got this tan theta 1 is equal to tan theta divided by cos alpha, and tan theta 2 is equal to tan theta divided by sin alpha. But we want a relation in cot. So just take the inverse. I mean, just take the reciprocal. So if we take the reciprocal, we'll get cot theta 1 is equal to cos alpha divided by tan theta, which is nothing but cot theta. Cos alpha into cot theta. Yes or no? Similarly, cot theta 2 will be equal to cot theta into sin alpha. This sin alpha that we got. Okay. This sin alpha that we got. 1 second. I'll just plug the laptop. 1 second. Okay, so this is cot theta 1 is equal to cos alpha into cot theta, and cot theta 2 is equal to cot theta into sin alpha. But we want square of that, so let's square and add. Cot square theta 1 is equal to cos square alpha into cot square theta. Okay, similarly cot square theta 2 will be equal to cos cot square theta into sine square alpha. Now we have to add them. In the right hand side we have cot square theta 1 plus cot square theta 2. If we add them, what will we get? For many students it will be clearly evident now itself, but I just want to show to everyone that we are able to get it. So cot square theta 1 plus cot square theta 2 will be, you see cot square is common, so I can take cot square theta common, and then I can add cos square theta plus sine square, so cos square alpha plus sine square alpha. And we already know that this identity cos square alpha plus sine square alpha will become, this entire thing will become 1. So it will be just cot square theta 1 plus cot square theta 2 is equal to cot square theta. We have proved it. Okay, that was question number 5. Let's move on to question number 6. A dip circle shows an apparent dip of 60 degree at a place where the true dip is 45 degree. If the dip circle is rotated through 90 degree, what apparent dip will it show? So here this is application of the previous question. In previous question we have seen theta 1 and theta 2 are two apparent dips in planes which are 90 degree to each other. So that's what is applicable here. So here a dip circle shows an apparent dip of 60 degree, that is not theta dash, we can write it as theta 1. So theta 1 is 60 degree at a place where true dip is 45. So theta is 45 degree. Now they are asking if the dip circle is rotated through 90 degree, what apparent dip will it show? That means theta 2 is equal to question mark. Matlab, now you have to find theta 2, the value of theta 2. So we can apply in the equation cot square theta 2 will be equal to cot square theta minus cot square theta 1. How did we get this? Because in the previous equation we got cot square theta 1 plus cot square theta 2 is equal to cot square theta. So we can write cot square theta 2 is equal to cot square theta minus cot square theta 1. So that's what I have written here. So directly you can substitute cot square theta. Cot theta is 45 degree. Cot theta will be 1. So cot square theta will also be 1. Minus, what is cot theta 1? Cot 60. Tan 60 is, tan 60 and cot 60, you remember the values, right? Tan 60 will be root 3. So cot 60 will be 1 by root 3. So this is cot square theta 1. So it will be square of 1 by root 3, which is nothing but 1 by 3. So 1 minus 1 by 3 will be, if you take LCM, it will become 3 minus 1, which is 2 divided by 3. So answer will be 2 by 3. But that is cot square theta 2. So cot theta 2 will be what? Cot theta 2 will be root of 2 by 3. So theta 2 will be cot inverse of this, and we can write it like that, cot inverse of root 2 by 3. And if you calculate it, you will get it approximately 51 degrees. So that was question number 6. Let's move on to the next question. At a certain location in Africa, a compass points 12 degree west of geographic north. What is this angle? I told before completing the question itself, you can write the given data. So what is the first data? 12 degree west of geographic north. We are seeing an angle between geographic meridian and the magnetic meridian, because compass points in the magnetic meridian and geographic north is in the geographic meridian. So what they are saying is nothing but phi, or what you learned as D, angle of declination. So this is angle of declination 12 degree west of geographic north, and we already, you remember, angle of declination will be negative if it is pointing towards west. So we will write it as minus 12 degrees. Now next, the north tip of the magnetic needle of a dip circle placed in the plane of magnetic meridian point 60 degree above the horizontal. Now whether it is above or below, for us it is the angle of dip. So angle of dip is nothing but 60 degree. Now why above or below is given? It is just to show whether the magnetic field is downwards or upwards. So can you tell me whether it is upwards or downwards? The north tip is upwards, and we know that magnetic field will be along the direction of outward from north. So magnetic field will be upward. That's one thing you have to understand from this question. Now let's proceed. The horizontal component of the Earth's field is measured to be 0.16 Gauss. You remember when in the beginning of the previous video I had discussed that the magnetic field is around 1 Gauss, which is 10 raised to minus 4 Tesla. So yes, this is the horizontal component which they are talking about, and horizontal component is 0.16 Gauss. So yes, we can write B with the suffix H is equal to 0.16 Gauss. Chalo. Now specify the direction and magnitude of Earth's field at the location. So clearly we have to find the magnitude. Magnitude is nothing but B is equal to BH divided by what? See, I'll show you with the figure so that it will be clear to you. So this is the angle of dip, and along the angle of dip you have the resultant or the actual magnetic field, and this component is BH, which is horizontal component. So horizontal component is given, and we know that B cos theta will be BH. So what will be B? B will be BH divided by cos theta, where theta is given, so we can clearly get it. It is 0.16 divided by cos 60, and cos 60 is nothing but 1 by 2. So if you have 1 by 2 in the denominator, that 2 will go in the numerator, and your answer will be B is equal to 0.32, which is nothing but 0.16 into 2, this many Gauss. And this is the magnitude. What is the direction then? Now the direction will be it is in a plane 12 degree west of geographic north. It is in a plane, that is a magnetic meridian. It is in a plane which is 12 degree west of geographic meridian. That's one thing. And then what? It is coming out of the Earth's surface at an angle of 60 degree. It is coming out of the Earth's surface at an angle of 60 degree, and its magnitude is 0.32 Gauss. So that is the solution to this question, and yes, that's it. So I hope you have understood the concept of the elements of Earth's magnetism. It's a pretty simple topic, and if you have understood completely, please let me know in your feedback. And until we meet again with another lecture, happy physicsing, and it's goodbye for me. Okay, bye.